I'm going to move on to the next speaker, which is Yoni Salzman, who is a project engineer for Honeybee Robotics. And Yoni is going to be talking to us about 3D printing for rapid prototyping. So take it away, Yoni.
Hey guys, how's it going? Just want to make sure that you can see presentation full screen. Look good to you?
Looking good.
Okay, great. So let's jump right into this. We are going to start talking about how we can integrate metal parts into our plastic parts. So a lot of plastic parts have lower tensile strengths, and that's something that is just a characteristic of plastic. And so metal can be helpful to integrate into your plastic parts. Not everything needs to be printed, and if you integrate certain metal parts, it can make your prototyping faster. Why metal? Well, a reason is it's just so much stronger. If you look here, I have plotted a bunch of different plastic parts, and then if you look below that, I also plotted, I took that one plot, made it really small, and then scaled it to add a standard steel nut. So steel is about 10 times stronger in most cases than plastic. So how do we connect parts together? Well, you don't need metal. You can tap directly into a plastic part, but it's not often the best. And what if you don't want to tap? Tapping is sometimes challenging. You could use a push-in insert. That's really quick and easy. Or if you want to go that next step, you could use a helical insert. Boss nuts, so you create a boss and then you put a nut in, is super easy too, and that's also very strong. So let's say you want to tap. How would you do that? You print your part, and you could get a tapping machine. That's very helpful. And you know, at Honeybee Robotics, we use a little tap stand all the time. It's very quick and easy. Buy some taps, they're really cheap. That tap stand, you can integrate a chuck, and you can tap directly into your plastic part. You don't even need metal. However, metal is really useful. So a boss is something that's very quick to put in your part. You can just, in your 3D modeling, you make a hexagon, and you make sure to size it for your specific nut. It's really quick and easy. Here are a bunch of examples of bosses for nuts, and that lets you connect parts very quickly. This is something that will allow your parts to stand up to higher loads, and you can use your parts in the real world, which is really exciting. They can undergo heavier loads. So how do you create those bosses for nuts? Well, there are a couple ways. You could just have a simple extrusion of a hexagon into a part, but you can also create more of a slot. In this blue part here on the right, you can see there are different types of slots. One constrains the flat sides of the nut, and one constrains the nut on an angled side. And you can also come in with that nut at an angle. There are all different ways to do this. So bosses for your nuts are really, really easy to do. I use them all the time for prototyping. Now, press-in inserts and helical inserts are great too. The press-in inserts are usually brass, so it's not going to be as strong as a steel, like most nuts are made out of steel, but the press-in inserts are quite easy and cheap and fast. You can put them in on an angled surface like you see in the lower left. And I just want to show you a little bit more how to do that very quickly. So you can just press it in with some type of press or, you know, a heavy weight or something to get it in there. But the best way is with heat. So that plastic is going to melt into the knurled surface of the press-in insert. And something that I'll mention a little bit later, but a really good technique is to take a standard bolt or a screw. It's made out of metal. And once you remove that heat, you want to screw it in there. This main picture in the middle here that shows the bolt inside the knurl shows how that bolt is in there. Why do you want to do that? It'll allow for better concentricity of that insert. If you don't have it when it cools down, it might not be circular. So what about helical inserts? Most people don't use this, but it's great They're very strong. You can get these inserts in all different types of materials, very strong stainless steels. I use these all the time. You can thread them right into your parts. They're very easy. My favorite brand is Helical. They're also pretty cheap, but you know, all different brands are out there. You can get second brands from a bunch of different websites, McMaster or Amazon. And here's a little chart. So let's say you want a certain size hole, let's say 440. So that's 40 threads per inch, it's size 4. You can look over at this chart and you can see, oh, look, I'm printing in plastic, so I'm going to model my hole as 0.12 diameter, 0.12 inches. And you can drill it out and you'll put that helicoil in. So it's really simple. How do you install it? Well, number one, we drill. So you want to make sure when you print a hole with an Ultimaker or any 3D printer, it's usually not exactly circular. So it's often good to drill it out. You drill it out, then you can check that your tap is the right size. Then you tap it. Then you insert your helical insert, or helicoil is a brand name. And then you can remove the tang at the bottom if you want, but you don't have to. They're great, and I'd recommend them. So what are other metal parts that you can integrate into your plastic parts? Well, bushings and bearings are really, really useful for low friction. Both bushings and bearings reduce friction. Bearings obviously reduce friction more because you have the spherical rolling elements in there. Here are just some different examples in a gearbox and just all different types of ways that you can integrate bearings. Gears are a really useful way to have bushings or bearings. And when you have higher loads, you often want that interface to be both the low friction and to withstand the load. So that's where bushings and bearings can be really helpful. So a really cool thing most people don't know, you can turn a really cheap insert into a bushing. So step one is upper left hand, you got your insert, you heat it up, you push it in, that's the middle top. Right top, you screw in your bolt so that it's concentric. Lower left on the bottom, you can drill it out, and then you can ream it, and then you can put in a little set screw on the side if you want to hold it in 100%. You probably don't need to do that, but this is a cheap and easy way to turn an insert into a bushing. So why not plastic bushings? Well, here's a really cool project. This guy, Joe Telling, he made a huge 47-pound all 3D printed car, except the batteries and a few electronic devices, but he made his bushings out of plastic, but it didn't work. It went for a few feet and then it didn't work because the lateral forces exerted on the axle by the drive belt created too higher forces that were too much. So he should have used a metal bushing in that case. So shafts and pins, another example of using metal. And this allows you to create really great gearboxes, and it's just another way to go forward. Magnets are really another metal part, allows you to make very intricate sculptures and can be used for actual engineering applications. You just pop a magnet in your part, you can press it in or you could glue it in. The best type of glues for metal to plastic are either two-part adhesives, which are most epoxies, or contact adhesives, which are usually neoprene-based. Both the Gorilla Glue two-part epoxy and the Loctite Stick and Seal Extreme Conditions for all temperatures are great options for connecting plastic parts to metal parts. You can also use metal for weights. Here somebody used pennies in a 3D printed enclosure, and then they had them as a weight on a piano to hold down a key. They were making experimental music. You could also use weights or other type of metal things for a lot of different applications. Here is a project I worked on. This is a wire rope termination for the next lunar rover. This is going to be the rover that explores for water ice on the south pole of the moon. This is a project I'm currently working on for Honeybee Robotics. So with my Ultimaker, I printed this little fitting for a wire rope. So you know, wire rope is another metal application, and we are prototyping this part. So lots of cool applications. And then bring it all together, and you can make some really cool assemblies with these techniques that I've talked about. So thank you guys very much, and I'll pass it back to Jeremy.
Wonderful. Thanks so much, Yoni. That was a great presentation. It really just opens up so many exciting possibilities of what you can do with 3D printing. So thanks for sharing that.